Hello, my name is Raúl del Busto Mendoza, and this is the video of my evidence 2, the solution of the problem situation for the class of modeling and automation. This is the simulation of our active suspension system. One model was given to us, and it will be considered as the more precise model. And the other model is the state space model we obtained and simulated for this project. Also, we have the parameters that were inputted on both models. I run the simulation with a perturbation of a step that can be considered like a car that passes an unevenness on the road. The results from this simulation were represented in these graphs. I took a screenshot of the results from the first model and the model we proposed. In the first graph, we can see in the blue line the displacement of one of the masses, and on the yellow line the displacement of the wheel. Here we see that after passing through the disturbance, the system stabilizes, and on the second graph we find that this behavior repeats, but with different values from the first graph. In the blue line we have the acceleration of the mass, and on the yellow line we have the displacement of the same mass. The difference of the results is due to the way we plan our state space model. In the first model, we were monitoring the position of both masses when they pass through the disturbance, but in our model, we are monitoring the acceleration and position of the mass too. So it is normal to see different results from this. Also, there are factors that we don't consider when we implement the state space model. So these too will affect the results we obtain from the simulation. In the case that we needed to represent a semi-active suspension, we need to take into account different variables to represent the model. This is because we can only change the way the energy is dissipated by the suspension, and that is it. So if we analyze the system on screen, I would recommend the damping force as our only controllable variable on the system. From there, we need to make our free body diagram and choose an output signal to obtain from the model. This could be the acceleration or position of the mass. This takes us to an interesting point of the video. This is the advantages and disadvantages of using simulations to develop a control system. Some of the advantages are that this gives us a general idea of what to expect from the final product. It is also a useful tool to know which variables are the most significant on the model, so we can discard some variables that affect our results, but they are not really important for the development of the product. And we can also detect errors in the system with the simulation, so we don't compromise the development of a product that doesn't satisfy the needs that we have. But to counter this, some disadvantages of using simulations are that they don't take into account all the variables. Some variables are complicated to represent. This can make the simulation a really complicated process to go through. And it is almost impossible to have an exact prediction. And also it is necessary to have previous data to analyze, and from there to develop the simulation. For this work, all my team was involved in the whole process, but we also divided some parts to prioritize during the development of the project. I was mainly responsible for the state space model we developed, but I also work on getting the simulation running correctly. Overall, I will say that we work very well as a team. I think that we were organized and happy with the results. To conclude, I can say that I am really happy with the results from this project, though we have some errors, and I never expected that we can have a model represented like this. I can say that it was very interesting for me. I found the use of the state space model to predict behaviors of dynamic system, and I hope to be able to apply this knowledge in different systems in the future. I truly think that it was a nice introduction to the control in my career. And this is all from my part. Thank you for your attention in this video.